Hello there, my name's Vince from My Mate Vince and welcome to another Advent repair, hopefully. So we are going to be looking at this, an air purifier. Nice little unit. To me it looks brand new, but it's not working. There doesn't seem to be any motor spinning. So if we turn it on, it comes alive and all of these touch things here work. Even the timer up here works, but yet there's no motor, there's no fan blowing anything, so it can't do any air purifying. Nice little touches. I was wondering what this bit is here, but I've read the instructions. You can add your own aroma, little droplets in here, and I presume then it disperses that into the room. So why is this not working? It's got a filter at the bottom. Again, it all looks new. I'll show you that when we're over at the mat. So let's take it apart and see if we can find out why the motor isn't working. Okay, the item is unplugged right now. If you're wondering what it is, an air purifier, well, it's got a HEPA filter in the bottom, and this one here. So you turn this, and this is the HEPA filter. And apparently, it has 3 lines of defense. So you've got your pre-filter, which captures particles such as fine fibers, dust, pollen, and pet dander. Then you've got the HEPA filter, which catches 99.97% of particles as small as 0.3 microns. And then you've got the activated carbon filter in the middle, which is supposed to neutralize household odors and VOCs. And I think it said you get 2,000 hours out of the filter. Yeah. And then the built-in sensor will alert with a red indicator, light turning on, and it's time to change the filter. Out of curiosity, I just want to see how much the filters are for this brand here. Okay, $16.99, but it's currently out of stock. It is a very popular model. I hope they come back into stock, otherwise I think people will be tempted just to go out and buy a new one. Right, okay. Because the price of the item isn't that much more. I think they're about 35 UK pounds, nearly 5-star rating. And yeah, loads of reviews. So obviously a very popular product. To be fair, it looks okay. Right, let's see how we get into this thing. I can see some screws at the bottom here. And I can see some screws here. So should we start at the top? I think we're going to start at the top, because then, well, mind you, well, the motor's at the bottom, but the wires for the motor are going to be at the top, I think. So let's start up here. I paid about £14 for this, which actually is cheaper than the filter, if you look at it that way, and I don't think this has ever been used. Right, I think we're going to have some clips. So let's gently go under here. Oh, lovely. Okay, we have a little connector, so let's undo that. Oh, we've got to pinch it. Well, so far, so good. We know that this is all working because the lights are lighting up. So now we have... Oh, there's a screw missing here. That's interesting. Maybe somebody's already been in here. I think we're going to do these ones next. Now, I don't know what my predictions are, but because it's brand new, I think it's going to be something... I'm going to say something very simple. I think it's just going to be a loose connection somewhere. But not that simple, because they look okay. I wonder, is it anything to do with the missing screw? Has it fallen in and got jammed somewhere, but then we'd hear it hum? Suddenly my confidence has gone down a lot. So we have the power coming into here, so I've got to be careful because there might still be, well, hopefully it would have drained away, but there might still be power on this board here. So this is the mains coming in from down here. We know that's all working. And we do have 3 wires going to this motor here. We can pull this out. So this is going down to the LED here. So first things first, let me see. That's a little sounder, is it? Let me see what value these are 400 volts, these little caps. So I'm going to try to measure them. I'm finding it quite hard to put pressure on it. Here we go. Okay, 6.9 volts, that's fine. Let's try the other one. 6.8. Fine. Okay, I'm happy to work on that. Actually, I know what I'm going to predict. I'm going to predict that there's a thermal fuse on this fan here somewhere, and that's gone. So let's undo this. And let's have a look where that connects to. So that connects to there. I think the solder joints look okay. Little chip down here, which is LN8K05. So there's a few things we could measure on there, but I don't think that's the problem. So I'm going to undo the connections from here. Okay, so we can move that out of the way for the time being. We do have something here. I wonder, is this the problem? Not sure what that is. Is it some sort of like startup capacitor or something? I really haven't got a clue. Does it even spin? Yeah, very free. Spins lovely and easy. I wonder, should we see if we can get resistances across here? So that's in the megohms. That's in the megohms. And that's not, that's 8 ohm between the red and the yellow. So I'm not going to be able to take it out because it's going to be attached to here, so I think we're going to have to undo some screws maybe. I don't really want to get involved in having to undo that nut. I think let's undo the, I was going to say the cable clips, but I don't know what that's going to give me. It's going to be a bit hard to work on it in there. I think I'm going to undo a few screws just to see what comes apart. See, the sensible thing would probably be to power it up and see what voltages we have on these pins. The problem is it involves powering it up, and it's going to be, I'm not sure that's going to be, it's going to be mains, isn't it? Yeah, look at the fuse. From the fuse, it goes straight to there, so it's going to be mains, and if possible, I'd rather not work on it when it's live. Okay, so that's loose there now. So maybe if I undo the bottom, it will come out this way. Mind you, it's not going to go past that, is it? Now this splits in half. I think I have to undo this, and the unit splits in half then. That will give me more access. Now, is there hidden screws under here? Yes. Right. Okay, more screws here and here. They would easily break. I'm wondering if I'm making life difficult for myself because it could be a problem on the circuit board. Okay, let's go back to the circuit board. Right, we'll get the meter on continuity, so it's going to beep. Let's see what's happening here. So we've got power coming in on these two here. We know that the fuse is working. Yeah, so it comes up to here. So that's direct to here. So that has to be working. Yeah. Then it goes to this diode and another diode. Where does this one go to? A resistor, down, into the connector there, and this one is what? Going into a transistor. Let's see if the transistors are the same. MAC 9788 and the same here. Maybe the transistors have gone faulty. Should we do a quick diode test? They are in circuit, but should we do a quick diode test on them? And also, let's just do a quick diode test on here as well. I'm only doing this because it saves me turning it on. Right, so no reading. No reading. Swap the leads. Reading. Reading, I think that's okay. Right, let's have a little look at these transistors. Something there. Something there. Nothing. I know, something there. And something there. Hold on. There. And there. There. So we're getting the same reading both way around. Okay. Okay, that seems a bit iffy to me. Let me see what's happening on this one. Remember, that one is in circuit. Now, we haven't got a reading there, so we've got a reading here. We haven't got a reading here. Let's swap the leads. Haven't got a reading there. So they're both testing, they're both showing different. I wonder, has it failed going to this middle one here? There's definitely a difference between the two. Just going to measure the resistors. I think I might unsolder those transistors. Right, so this should be 470 ohms, which it is. This should be 470. Ooh. I think there's quite a lot of conformal coating on the board, so it's hard to get a reading. This one, that's not measuring correct. That's not right. That's 471 should be 470 ohms. And it's reading 443,000 ohms. I'm pretty sure. Let's have a look at this one. Yeah, that's fine, 47 ohms. Sorry, 470. I think we need to take this resistor out and then see if the transistor readings change, because that definitely isn't right. Definitely isn't right. Let's get that one out of circuit. I'm just going to see if I can do it with my soldering iron. Just going to get some blue tack. In fact, does it or does it not look damaged in the middle? Can you see compared to the other two? It does, doesn't it? And I think they are, aren't they? They're wave soldered. This is going to be annoying to come off. Can you see the bits of glue just here where the solder's pointing to? So these are wave soldered on, so this is going to be a nightmare. I might have to use hot air to take this off. I'm going to have to use hot air, otherwise I will just break. I will just break it. Annoying. Wow, that came off unbelievably easy. Right, I've got it in some blue tack, stop it pinging off. Let's see what it's reading now out of circuit. No, that's not right. There you go. 0.6 megohms, that's definitely not right. Okay, so we found one faulty thing. Let's see now if this is, let's see if the, on diode test, is this still measuring weird? Yeah, it is. I think we're going to have to take out both transistors and then we'll measure them out of circuit. They're supposed to be the same. I think I'm going to get my desolder station on. Came out nice and easy. And nice and easy. Oh, a triac. Oh, I've heard Buy It, Fix It mention these. So that's what's running the motor. A triac runs a motor, I believe. I've also come across them in something else, but I don't know what. Triac. Might have been the massager from ages ago, actually. See, I was thinking they were going to look like a transistor. Ooh, well, there we go. It's different, isn't it? Resistor. 2 resistors. Problem is I haven't got any triacs, which is annoying. And, oh, is that scratched? Ah, here we go, it's cracked. It's cracked across here. Okay, right, we need a new one of them, and we need a new resistor. I wonder, is the rest testing okay? It's annoying that I haven't got any of them. I thought they were going to be a transistor. Right, let me see. Hold on, we got another one here. 97A8. We got another one here. So what's that? Is that coming? Oh, and that feeds that one. So that one, that triac's feeding that triac. And also, that triac is going under here, I think, and feeding this one as well. So I suppose we better unsolder that one, or at least test it in circuit. So is that there? Yeah, that's feeding that as well. So that's feeding that. I think we better undo this one and just make sure that's okay, because I don't want to, if I'm ordering them, I don't want to have to, you know, I don't know how much they're going to be. I'll probably get more than one, but I just want to check this one as well. Right, let's see if this is the triac. Fantastic. Okay, good old component tester. I am going to Google these and see how much they are, and even if I can get them. Right, Farnell have them for very little money indeed. So they're only, you have to buy 5 of them, but they're only 30p each, excluding VAT. So like 38p, call it 40p each. So it's not a lot of money at all. And if you look at the data sheet, well, sorry, there you go. It's £1.50 excluding VAT for 5 of them. So £1.80 something for 5. And if you have a look at the data sheets, the gate of them, yeah, the gate of them is the middle one here. See, number 2, the middle one is the gate. And then we have terminal 1 and terminal 2. So now if we look at the gate, you can now see that the gate here, so let's get this round this way. So the gate here goes through our resistor, which is now gone, and it goes up here on this thin track to here, which is the connector that goes up to the display. So clearly when you press the display that you want to put the fan on, it will liven up this one here, because it's going to the gate here to turn on this one, which will then turn on the fan. Now remember, we have the live from the fan constantly here. What I'm thinking now is, you know, the desktop fan that we did. Do you remember you had different speeds depending on the winding? Well, now look, if we go from this one here, can you see it goes through here? It's on this middle one. It goes to this one here. So I think when you select maybe fan 2 at the top, it will liven up both triacs and it will liven up another coil. I'm just a little bit confused about what this one here is for then. Because look, this also goes up on this one, goes to here. So that also goes up to this connector. Have we got like one and then... Because this is linked, isn't it? This is linked to that. Is it because this one is a bigger winding that it needs 2 triacs to make it more powerful, to handle more current or something? I'm not sure, but I think that's what's going on there. So then there's going to be, it's giving you different, it's going to basically spin faster, just like the desktop fan. I think that's what's happening. So I'm going to need to buy a triac, and I will probably have one of these, but let me see. Well, I've got a slight problem with the resistors as well. So I need a 1206 size. This is the one that's blown. And if I place it on my SMD ruler, you can see that it fits on the... It's a bit hard to tell because there's a big lump of solder on it, but it looks like it fits on the 1206. Now, I've got capacitors that are 1206 size, because you can see it says here 1206. And if you have a look, you can see that they're the identical size here. Yeah. Now, the biggest resistors I have, SMD, are... these ones here, and these are not 1206, these are 0805, and they're considerably smaller. You can see they're the next size down. So I don't want to put in one of these because maybe it's not going to be able to cope with the current. So I also need to get a 471 1206 resistor. So I'm going to write that down. Okay, fine, I'll have them. Ignore this here. I think that's just the same picture, like a library pick for all different values. But if you have a look here, you can get 10 of them for what, a 10p each. So it's going to be £1 excluding VAT for 10 of them. And if I click on them, it says that they're 1206, 470 ohm. And if you have a look down here under product information, it does say that it's 500 volts. Because remember, this is mains. I think this one will be okay. So there's certainly more wrong with it than I thought there was going to be, but it's certainly more interesting. I'm just going to say that because it looks brand new, I think maybe the triac was faulty from the very beginning, unless somehow somebody jammed the motor up when it was starting up, because you're supposed to take the wrapping off the filter. Maybe they didn't, and the wrapping got caught in the bottom of the filter, and maybe that jammed it up. And then maybe too much current went through. I hope the windings off the motor are going to be okay. Actually, do you know what would be interesting? Do you know what I'm going to do? I am going to put the good triac here because I think this is for speed 1. I'm going to put the good triac here, and I'm going to move the resistor from here to here, and then I'm going to plug it back in. And I'm going to put the triac here again. So we're removing the triac from here and put the good triac in, and let's leave this one empty. Let's see if it will work then, or does it need all the triacs to work? See, I don't think it does, because I think they're livening up different windings. That's what we're going to do. Actually, I might just see if I've got a 470 ohm resistor in here. Or, one second, can I not put a surface mount one in? 470. I'll put a through hole one in. No, that's 470k, bear with me. 470R, there you go. I'll put one of these in. So that is what we shall do. Let's stick the through hole component as a surface mount component, and let's put the triac back in on the right hand side of the board, and let's put the other triac back in, but put it where the blown one was, and hopefully let's see if it starts working on speed 1. If it does, fantastic. I can finish up the video, I can order a triac and a proper SMD resistor, and then we know that this should be working on both speeds. If it doesn't work when it's there, Maybe there's a problem with the motor, and maybe the motor has caused this circuit board to self-destruct with the triac and the resistor. Okay, that's my bodgy resistor there. You can see it is jumping over that bit there, so that side's not near it. And so now we should have 470 ohms between the middle of the triac and the path going up here. So let me just make sure, because I didn't measure the resistor beforehand. There we go. 465 ohms, because it's points, because it's in the 1000 ohm scale. I really have not got a clue whether or not this is going to give anything, or will it just burn up and blow straight away. And if it does burn up and blow straight away, I don't know if it's going to be the coil of the motor or whether I've done something very wrong here. I'm hoping it's not like a brushless motor that needs different feeds to make it turn. I'm sure it's going to be different speeds. Amazingly, I didn't want it to come off, and now it's come off no bother at all. So it looks like you have to lift the whole thing up to get it off. Okay, the circuit board fits just down in here. So I'm just going to rest this on here and rest this on here. And now I think I feel quite safe touching it. And if it explodes, the triac shouldn't hit me. I'm going to plug it in now. I have no idea what's going to happen. Please do not copy what you see in my videos. Take them purely for entertainment, if you can call it that. Now, let's see what's going to go on. There's quite a few of you that may know what's going to happen. There's quite a few of you that are going to be like me that don't know what's going to happen. I'm going to say it's going to work on speed 1. Right, here we go. I'm plugging it in now. Okay, that's fine. Nothing's exploded yet. So now I'm going to touch this and see if it starts working. No. What? I thought that would have worked. Now I'm worried. So the fan is still not spinning. It's the same as it was earlier. I can't hear anything attempting to work either. I'm not so confident now. Actually, I think I can hear it trying. I can hear a slight buzzing on the speed number 1. I can hear a bit buzzing now. Right, just in case it needs the filter at the bottom, I'm going to unplug it. And I'm going to put the filter in, but I don't remember seeing any sensors. They were just LEDs down there. Yeah, that's not going to make a difference, is it? No, there's nothing there to say. Yeah, I'm not convinced now. Maybe the motor has blown and it took the triac out and the resistor. I don't think a resistor and a triac is going to fix this. I'll plug it in again. I can definitely hear a little bit very. Well, that's massively disappointing, but then again, I suppose you need to think what took out the triac and the resistor in the first place. Why was too much current drawn to blow them up? I look at it again, and this time I concentrate more on the motor. Annoyingly, the motor is very hard to get to. There's a couple of cable ties on there. But when I cut back the cable ties and actually look what's underneath the insulation sleeves, I then find this. I'm going to cut this cable tie. Look, we've got burning. Let's turn this off a minute so we can hear. We've got burning. Yeah, it's very burnt here. I think it's the motor that's gone, you know. Look at the windings on the motor. I think the motor's gone. Now I don't want to scrape, I'm just going to use plastic, I don't want to scrape that enamel back. I just want to see it all looks a bit glistening. That don't look right. That doesn't look right there. I mean, I should be able to measure the coils, I would have thought. I think maybe the coils have shorted and it drew too much current, which blew the triac. I'm chopping all this now. I'm not convinced that this motor's working. Here we go. I've got to be really careful because this will break here very easy. In fact, even that looks a little bit mangled up. Right, here we go. Something's just come apart here. And this has just broken. So that's broken. I don't know if that was me, whether that was broken beforehand. What we got going on here? Is this a thermal fuse? Yes, it is. Should we see if the thermal fuse has blown? Zoom in, see what it is. I don't think this is a fixable one, unfortunately. I've still enjoyed it though. So this is 130 degrees Celsius, 2 amp, 250 volts, so 130 degrees Celsius. Let's see if you are blown. So I'm going to take this off here, and this one here. Okay, now we get our meter in continuity. What do you think, yes or no? I think yes. Thermal fuse is gone. Okay. Yeah. So the thermal fuse is gone. I'm just going to use my eye loop. I'm going to look real close in here just to see if I can see any of the windings. The problem is I'm just going to be measuring for ohms. And even if these windings were all measured, shorted together, like a good winding, I don't know. Well, actually, no, on something like this, it probably would be high. I was going to say on that little brushless motor that I did on the drone, they were only 2 ohms, weren't they? But something like this should be more. But what I was going to say is, let's say on that little drone, all of these could be completely melted together and they might be near enough measuring 2 ohms. And then a good one might be measuring 2 ohms, you know, well, especially on my meter anyway. My meter can read 4 or 5 ohms by touching the leads together. Now, this is quite promising. If I go across the other ones, maybe the coil isn't melted together. If I go, so we've got the blue one, which goes through the thermal fuse onto the black one. The black one goes down to this, I'm going to call it a startup capacitor. I have no idea what it is. And then the white one comes back and goes down a winding. But the black one also goes onto the winding that's broken. But if I go onto red, my fingers are all over it because I don't want to break anything. But if I go between red and yellow, this looks like a winding, 123 ohms. If I go between red and white, this looks like a winding. That is 300 ohms. And if I go between white and yellow, we have, see, this is why I have to touch it, 180 ohms. So now what I'm going to do is this black one here, I'm going to try to extend a new bit of wire. It's right the way deep in here. I'll show it to you, but I'm not going to be able to film it because I have to have this at an angle and my head's going to be right in the way. But basically it is this one here which is broken. So can you see? This one, I think it's this one here, hold on. Where's it gone now? So annoyingly, it is kind of tucked away. But I'm going to see if I can melt the end of that and get a tiny bit of solder on. I can always cover it in like, for example, UV mask or nail varnish or something. Or even hot glue, probably cover it in hot glue. If I can extend that out, I've got wire which is 0.3, which is going to be probably a similar, well, this is quite a bit bigger actually. I'll use some 0.1mm wire, that's probably very similar to it, and then I'll extend it onto the black one here. So I'm just going to do that off camera because I won't be able to, unfortunately, film that on camera. It's going to be incredibly hard because of the size of it. But yeah, it'd be okay. And then I might just put a temporary fuse in just to see if it starts working. Because I haven't got any of those in 130 degrees. But I'm here, I'm not leaving it on, this is only for testing. So what happens now is I spend about 1 hour trying to get this motor sorted out with all the little windings. It's incredibly complicated because there's just enamelled wire everywhere. You can see me attempting to solder together 2 bits of wire here. These are 0.1 millimeters. It's hard to understand how small that is, but you can barely see it. Basically, a 15 centimeter ruler would have 1,500 of these wires in. A 30 centimeter ruler would have 3,000 of these wires in. That's how small they are. We're talking tiny. Anyway, I managed to solder this one together. This is the one that's feeding the black wire that goes to the thermal fuse. But then that wraps around the coil, however many meters in that coil, I don't know, let's say 100 meters of enamelled wire. And then it comes out of that coil and it goes to the coil opposite, 180 degrees away from it. And it wraps around that one. But annoyingly, there's no wire coming out of that one because it's broken somewhere. I do find a wire on its own, but the thing is, with my messing with it, I may have broken multiple wires. These are all very small wires that you're dealing with, and everything's all kind of knotted together and stuff. But I do find a wire that's not doing anything. So I unravel it a bit from the coil, and then I solder that onto the red wire. So we have 2 wires going to the yellow one and 2 wires going to the red one, and then we've got the black wire from the thermal fuse feeding it. The black wire from the thermal fuse also goes off to feed that startup capacitor, which comes back on a white wire, which also feeds something. I don't know what. Anyway, I put a little bit of nail varnish on the wires that I've soldered, and I also put a bit of hot glue on them as well, just to try to make them a little bit stronger, because otherwise they might just vibrate loose. Then I need to crimp on my thermal fuse. Now, I thought you need to buy a special tool for this. Thank you to everybody that told me. I've already got a crimper that does the ferrules that you put on the end of wires, you know, so stranded wires, so you've got a nice connection if you're screwing into them. And people said to me, just cut off the coloured bit. So that's exactly what I did. It's brilliant now. I never have to worry about having to solder thermal fuses again, because these work really, really well. I've got all different sizes. You just cut off the ends, you know, the plastic bit, and you're just left then with a kind of aluminium style tube, and then you just put it over the thing you want to crimp and use the crimper, and it seems to do a really, really good job. So a massive thank you, because I thought you had to buy special crimpers and a tool, but no, this thing here works absolutely perfectly. So yeah, well happy with that. So there is about an hour that's gone from this video that you haven't seen, but there was a lot of hard work put into it. The thing I've got is that I don't know really what windings there should be, because on 2 of the coils there's definitely 2 wires coming into them and 2 wires coming out, so it's all very, very confusing. So let's pick up the video now that I think I've soldered the damaged wires and I've crimped on the thermal fuse. So this is how I think it's working. And please correct me if I've got anything wrong in the comments, which will probably be most of it. I think the main power is going down the blue wire here, which goes to, I think it was this one here, which is then linked to this coil, which then goes to the red, which goes through this triac here and makes the circuit. So if you imagine if these coils were like a light bulb in series with each other, so basically this is going to light up and this is going to light up because it's going through the triac and making the circuit. The middle, the gate of the triac goes up to the touch panel at the top. So we're deciding to turn the gate on by pressing the button, and that's then what joins the triac together, I think, and that's what makes the circuit. I think then when we go on to value number 2, fan speed number 2, I think then the other triac turns on, and because from this red wire we have 2 wires, I think the other wire is then feeding the other 2 coils, and then it goes through the other triac, which is missing, and makes the circuit as well. I think that's what's happening. So I think this is like the main triac here, and then these are the two ones for either speed. But I could be completely and utterly wrong, and maybe you need all three triacs to make it work. So now I've got to somehow try to get this thermal fuse against the coil, and I don't know which coil it went against. So I think I'm going to have to try to watch back the video, because I don't know which one to put it against, you see, because they're not always going to be all energized, I don't think. See, I might have that completely wrong, and maybe all 4 coils do need to work. I mean, would a motor work with 2, one here and one here? Maybe you do need 2, and the reason we have 2 wires from here and 2 wires from here is that there's more windings. It could be as simple as that, so this still might not work actually. Right, okay, it's incredibly hard to know what's going on. I've just put it down in here. When I come to edit the video back, I'll see it on a big screen, so maybe I can change it then. I can't even get the cable ties in the correct position. So, yeah, I don't think this is... Do you know what? I'm not even convinced with the windings anyway, because if we have a look here, there just seems to be such a difference between them. So if I go between the blue and the red, I mean, it's good. We now have readings. So we've now got 28 ohms, call it 30 ohms to make it easy. If we go between the blue and the yellow, we have 150 ohms. And if we go between the yellow and the red, we have 125 ohms. So I suppose if you were to add that to that, 30, so what's that, 155? Yeah. So it kind of adds up, I think. It's just that I'm a bit worried why that just seems so low. My other thing I'm wondering is, again, I don't know if I've said it already in the video, if I had a triac, I'd put it in, of course I would, but I haven't. And I'm trying to get these Advent ones done in the day. These are not rare, I can get them easily. It's just that I need to get this video released today. The other thing I'm wondering is, so a triac isn't like a transistor in that it doesn't adjust anything. When the gate gets triggered, I think it's just all on. So it's just like a switch on and off. I could be completely wrong there. So what I'm wondering is, if I do this and it doesn't work, if I do this now and it works on 1 speed, fantastic. I know that I fixed it and I just need to get a triac. But if it doesn't work, I'm now thinking that it needs all 4 coils to make the motor actually spin. And the reason we have the double wires is because that's when it goes off on the yellow one. So I think it's not going to work right now. I thought it would work, but now I'm thinking it's not going to work because we need a triac. But if I was just to jumper from here to here, forgetting about the gate, if I was just to jumper it, that would then liven up those coils, I'm thinking. In which case then, I can't control the speeds. But again, we've then proved that it's now working. We just need a triac. So to begin with, I'm not going to jumper that up because it could be very dangerous. But if it doesn't work on 1 speed now, I will jumper that up. And then I think we're just going to have kind of like max speed. So yeah, right, let me put the rest back together. I'll start filming when I'm about to turn it on. Okay, I've got it back together enough to test. Yeah, that's in there. Everything's connected. The motor is spinning freely. We might be able to see it. I've got it plugged into an extension lead. I'm going to go across the room and turn it on. And if it goes bang, I'm not doing any more. If it doesn't go bang, then I'll try to turn it on here and we'll see what happens. Right, turn it on now. Okay, hasn't gone bang. I'm making my way over. Let's turn it on and see what happens. I'm going to try to hold it here. Whoa. Okay, that went bang. Ooh. Well, something definitely fizzled. Okay, let's see. Has the triac blown again? Ah, well, at least we got a fizzle out of it. Yeah, there you go. Triac's gone again. This time it's blown really nicely. Well, I don't need to do any more now. Look at that. Check that out. So triac's gone again. Same one as before. I wonder, has it all... That's really gone good. Look at that. Amazing. Right, let me just check for voltage. I want to see if the resistor's also blown. There we go, look at that. That is burnt out nicely. Can you see it's all burnt in this area here? So we got the same fault conditions as we did at the beginning. A burnt out resistor and a burnt out triac as well. So this is what I think's happened. Normally when you buy this is fitted in the bottom, but it comes with a plastic bag, like so. And it says here, the appliance comes with a filter fitted inside. Do remember to remove the packaging of the filters before use. I think the original owner didn't, and I think the plastic bag got sucked up into here, stopped the fan from spinning. I think the coil burnt out, which took out the thermal fuse, and before it did that, it took out the resistor and also the triac as well, because too much current was drawn. That's what I believe. I don't believe that this motor is fixable because I think the windings have burnt out. If I had a working one, I would test these wires here for resistance, and I bet we find that between the blue and the red should be maybe 120 ohms, and then the difference between the blue and the yellow should be then the 125 or whatever it is, 150. I bet you there's only supposed to be about 20 or 30 ohms difference. Well, what we've got is 30 ohms here, and then I think we had, was it 125 ohms here. I think what's happened is where the windings have got the scorch mark on them, I think the windings are burnt together. They should be enamelled wires, so they should be separate from each other, but I think maybe they're conducting to each other, and that's why we're not getting the correct ohm reading, because we have a massive short going across that there. We've probably still got maybe 130 meters of windings that are not shorted, but if it's expecting to see 250 meters of windings not shorted, then that's the difference between maybe the 30 ohm reading and the 100 ohm reading. That's what I think anyway. So to get this working, I believe you're going to need a new motor, you're going to need a resistor and a triac. So it could all be done. Interestingly, this motor is down, when I had a look at it, as a 110 volt motor, 60 hertz. Yet in the UK, we are going to have 240 volts and we're going to have 50 hertz. So a bit strange how that motor's fitted to this one. I'll be expecting to see maybe a 220 to 240 volt motor, but it's definitely a 110 volt motor. I'll try to get a little bit of footage of that if I can. And yeah, by the time you've bought that, and that, you may as well buy another working unit, because if you get a working unit, you're going to get a filter with it as well, and these filters cost about £16 or £17 when they're in stock. So add up the price of that, the motor, the triac and the resistor, and you're not far off a new unit, and then you haven't got all this horrible burnt wires here. So personally, I've done my best on this, and it is repairable, but I would need a lot more time to repair it, and I would need spare parts, which I'm not going to do because it's not economically viable. I thought I may be able to do it by just kind of bodging up the wires here and doing the triac in a different place and stuff like that. But correct me if I'm wrong with my diagnosis of that. I could be completely wrong. Maybe you do need all 3 triacs. The other thing I'd like to know is, do you definitely need all 4 coils? I'm now thinking you do, and I'm thinking the double windings on here and here are the ones for the different speeds. So I think it's going to be all 4 working on one speed, and then the double windings kick in for the extra speed on these 2 here. That's what I think anyway, looking at how that's wired up. So yeah, not everything can be fixable when you're trying to do a video day by day. And also it's good to show failures as well as successes, because then it makes the fixes all the more enjoyable, and it makes people less upset when something goes wrong for them, because failures happen all the time to everybody. So that is it. Not successful today. Hopefully, fingers crossed, I will be successful tomorrow. If you enjoyed this video, give it a massive thumbs up, and I will see you all very soon. Thanks for watching.